Hi, in this video we're going to find the area of a kite. Now remember, kite is, well, other than being an object you fly, it is a quadrilateral or four-sided shape where you have two adjacent sides next to each other with the same length, and the two other sides have the same length. And now a kite has a line of symmetry, so we could divide it into two like this, and we get two triangles. But more than that, because we've got this line here is tangent to this section of the circle here. By a tangent, I mean this line touches this circle here. Then the angle between a tangent and the radius of the circle at the same point is 90 degrees. So it looks like 90 degrees, and that's because it is 90 degrees. This angle here is going to be 90 degrees. And that's great because now we've got two right angled triangles and we can find the area of a right angled triangle. So let's just concentrate on what we know about, say, this triangle here. Well, because this is a line of symmetry, those two angles here and here are going to be the same. So we can just halve the 118 to give you 59. So this angle here is 59 degrees. And let's just draw this triangle out separately. We've got this triangle like this. And this is a right angle. We've got this as 6. And we've got this angle here is 59 degrees. And what do we actually want to find? Well, to find the area of a triangle, we could do half times base times height, couldn't we? But what do we use as the base and the height? Well, the base and the height have to be at right angles to each other. So we could use this as the base and this as the height, because they're right angles to each other. Now we know the 6, so we need to work out this base here. So we can just use trigonometry because it's a right angled triangle, right? This is the angle of interest. It's the angle that's labelled that's not the right angle. And then the two sides of interest are this 6 here and this side we're trying to work out. Now we don't know what it is, so let's put an X there. And then remember, we label the sides relative to this angle of interest. Now this X is opposite to this angle of interest, so we label as O for opposite. And the 6 there is next to that angle, which we say is adjacent to, so we label it with A. Now, remember our mnemonic, we can use SO, CA, TOA to determine which trigonometric ratio we use. Now, because we're involving the O and the A, we can see the O and the A are here, so we're going to use that one there. And remember what this was short for? This was short for tan of the angle of interest. That letter there is theta, it's just a Greek letter for angles, and then is equal to O over A. So O over A, like that. So let's just substitute our lengths in and our angles. We've got tan of the angle, which this is the angle of interest, the theta there, 59 degrees, is the O over the A, so the X over 6. Just multiply both sides by 6 to get rid of that over 6. You get X is equal to 6 tan 59. Let's do that in our calculator. And we get 9.9857. 7, that will do. Okay, right, so we've got that length there, which in this diagram is here, the 9.9857. And now we can find what the area of each triangle is. So let's just do it over here. The area of that triangle is half times base times height. So the base, we're going to make the 9.9857. And the perpendicular height, we're going to make the 6. And if we do that, we get 29.957. So that's the area of just one of these triangles, but we've got two of them, so we just need to double it. So the total area of the kite is just going to be 2 times that area we found. I times it by 2, and that gives me 59 point, how many decimal places? 1, so 59.9 in centimetres squared. So that's the final answer. The area of the kite is 59.9 centimetres squared. And we're done.